Okay, so the next layer on the Android architecture stack above Android runtime, which we just discussed, is the layer of native libraries. So what we have in native libraries is the libraries that are written in C and C++ or several lower level native operations, right? So several Android system components and services, they require native libraries written in these languages, which directly deal with uh, some of the hardware components, like graphics and so on, graphic drivers and so on. So the Java API frameworks, they expose certain functionalities of some of these native libraries to our apps. For example, OpenGL, which supports drawing and manipulating of 2D and 3D graphics, that is a native C++ library, but you'll have an OpenGL API exposed through the layer above this. You can also develop native apps directly using some of these libraries, using what is called the Native Development Kit, the NDK, and we'll treat it as an advanced topic towards the end of this semester. Okay, so we'll perhaps talk a little bit about it, maybe through the student projects or student presentations about the native development. Why would you do that though? Why not just use the high-level Java or Kotlin APIs for, like the OpenGL example here, for graphics rendering and things like that? So the answer to that question is, and many of you have perhaps guessed, it's performance. So Java is considerably slower than C, C++ in general, and also on Android. And rendering graphics, 2D and 3D graphics using, say, those lower level libraries directly will be much more efficient than using the Java APIs, which are layered on top of several other things. Okay. So that's the primary reason why people may want to do some native development. Moving on to the next layer, we have the API framework, also called Android framework sometimes. And this is the layer which exposes the APIs that are going to be used by the layer above that, which is basically the apps layer. When we say apps, these can be all sorts of apps, not necessarily the system apps or just the user-defined apps, but all the apps are considered equal in that sense. What that means is the same set of APIs is available to you as a developer as it is to Google developers themselves for designing, say, any system apps like the clock or the browser, etc. What does this layer have? So this is basically the topmost abstraction layer. As you can see above this, you have apps which you and I can develop. This makes all the features in this stack available through certain Java APIs. That is the purpose of this layer. So you should be able to use any features of the lower layers through the APIs. And again, for, say, performance reasons, you may want to choose the NDK APIs rather than the SDK APIs that this layer is talking about. But that's a different matter. The point is, this layer exposes all the capabilities of Android for your app development. It contains what can be considered a reusable software. So several libraries which simplify a developer's life by making certain aspects, certain reusable aspects available. For example, all the graphical elements like a text box in that hello world example you have seen, or a button which upon clicking should invoke a method, things like that are part of this API framework. So you don't have to recreate a button again and again. That's the idea. And as the last bullet point says here, this layer is going to provide the building blocks for all our apps. We'll take a look at some of the systems in this layer next. So first one is a view system. As you can imagine, it contains the common GUI elements like the buttons, the edit text, the icons, etc. And here is an example. The default clock app that you see on many devices. So what we have in that is here you have tabs which are in the top level UI. You have different tabs for, say, the alarm, then the stopwatch, then the timer, and so on, right? So you click on those and the view here changes. A new view loads for you to manipulate and deal with it. You also have a panel of several buttons which makes up the keypad. So each of these digits is basically a button, and those buttons are also coming from the view system, and the layout on which this was put together is also coming from the view system. And we also see an example of how the view system responds. So, the app listens to these buttons being pressed, and when the button press happens, there is a listener which responds by showing, say, the 5 or the 0 or whatever over here. Okay? So this is broadly what the view system has, and we are going to deal a lot with the view system. All the apps we create will have the GUI component. So we'll come back to that later. The other thing in the API framework is the package manager. Again, as the name suggests, you can perhaps guess what it does. It's going to keep track of all the apps installed on the system. So the package, the APK we talked about, this particular entity is going to manage those packages, as in the app. The apps that you installed, they get their icon placed on what's called the home screen. And each icon here is basically an application package that is installed on the device. Right? You won't have anything that's not installed still show up here. And if an app is installed, it must show up here. You can choose to place certain icons on, say, the device screen for shortcuts, or somewhere else for shortcuts. But this launcher is going to have all of them. Yeah. This package manager is also responsible for certain inter-app communication, like finding and contacting other apps for sharing data, requesting certain services, like shooting an SMS. If your app needs that functionality, most likely you won't implement it yourself unless you are creating a messenger, of course. But otherwise, you won't want to do it yourself, but instead just delegate it to the existing texting or SMS app. And that's an example of what it's talking here. You also have what's called a window manager, which, again, as the name suggests, manages various windows that make up an application and that show up on the screen. Let's look at an example. So here again, a different tab on the clock app. Here you are looking at all the alarms that I have. And first you see, the first window you see is the system's notification bar. This very narrow, thin line at the top, which, as we can see, has the battery status, the current time, and some notification about an external card apparently, and network status and things like that. The other thing we see is the main application window, the main area in which your app is going to run. And in this case, it has the 6:30 alarm for my weekdays and a 7 o'clock alarm for my weekends. Let's say I want to have 30 minutes additional sleep on weekends, so something like that. And it also has this sub window for different menus. So here you can click and check and select, say, the night mode or the light mode and additional settings for this app. This is what you can get at by clicking the hamburger icon, for example, in some apps. Another component of the API framework is the resource manager. Resource is a term we use for all the non-compiled resources in the Android app. And by non-compiled, we'll go into the details later, are largely the resources that are given in the XML files. So for the upcoming assignment where you have to set up the IDE and then change the greetings hello world to hello your name, you'll have to go and make changes in the strings basically. And that string, the string hello world is written in an XML file. You have to change it to hello, comma, your name. And that is a non-compiled resource. No? It is not part of your Java code. It is not compiled by Java C directly, but it's made available through the resources. Similarly, layout files, files that tell us how and where to put different UI elements, like this floating plus on this screen. That's a button, a floating button, and you get to decide where to put it. You get to decide how many alarms to show on the screen, what should happen if there are too many and you scroll, and things like that. It's always a good idea to externalize the app resources. That is, do not create strings, for example, in your Java file. Instead, rely on these XML resources, which are external to the Java file. I'll briefly talk about the advantage of this. We'll see how to use this for the example given much later in the course. So if you observed, let me go back to the previous one. Where we had the alarm. So this alarm is being used on a device that has English as the language. So you can see the Monday, Tuesday, Wednesday, etc. for the days of the week, right? But here you might have observed it says it has different names. It has Lun, Mar, Me, etc. I don't know Spanish, but I just use these by looking up Spanish translation for days of the week. So how does this come into the picture here? If you use the resources in Java, then at all the places where you're going to use the Spanish names, you'll have to write it in your Java code. Whereas if you choose to go with externalizing the resources as we have done here, you can basically create different string files and just have them contain the string resources appropriately. And then based on the device configuration, that is what language the device is using, your app, the device, and through that your app chooses the appropriate language. So the Java code for the Spanish names for the days of the week and the Java code for the previous screen where we saw the English names for the days of the week is not different. It's just the same. We just have an additional resource file, and then based on the device settings, the appropriate resource file is loaded. So that's the advantage of externalizing the resources, right? You also have what's called an activity manager. Activity will come to looking into it pretty soon, but an activity is essentially the fundamental building block of an Android app. Well, one of the few, but the most commonly used one, because that is the entry point for users' interactions. Any screen you see is essentially an activity, and we load several buttons and other UI widgets on that activity, and then the user interacts with those. So there is a specialized manager for managing these activities. And an important task is what happens when you move from one activity to another. For example, here when we had the alarms selected in the top left screenshot, of the mobile device here, you had the alarm selected. If you click on the stopwatch tab, you get this screen on the right, which lets you put in a time, and then if you click the play button, the stopwatch will start. Now the question is, what happens if I go back to my list of alarms? Should it have my 6:30 and 7 o'clock alarm? The user expects yes, but how is it managed? How is it preserved even when you move from one screen to another? That is the job of the activity manager. You can override some things. There are certain behaviors that are by default unexpected, and the developer has to take care of working and making sure that the behavior is as the user expects. For example, let's look at the portrait screen on the right, which shows the stopwatch in this portrait view, and then the landscape view of the same stopwatch activity. Okay, what we see here is a slightly modified UI because it looks better. You are still able to access all the elements, the amount of time showed on the stopwatch, the play button, and the keypad in both the views. You'll be perhaps surprised to know that without taking proper care, if you just rotate the device from portrait to landscape and vice versa, in both cases, you're not likely to retain the UI state. That's going to be a topic of discussion for at least 2 lectures that will come to next week. But yeah, activity manager is responsible for handling, say, orientation change and moving from one activity to another. Next, we have a notification manager. Notifications, as you can imagine, are sometimes the appropriate information that needs to be shown even in the middle of the app, and mainly outside the UI of the app. So you get a notification about a new email, you can get notification about low battery status, and so on. Okay. And these can take the user to the appropriate action in the app. Okay, so there are various ways they can appear in the current version of the more recent versions of Android. We are going to look at some of the pictures here. All of them are taken from the Android documentation. Okay, so yeah. The first one is, and most common one perhaps, is a notification in the status bar and the notification drawer. So it shows up at the top, like the unread email symbol or icon here. You pull down on that, and then you see the notification. You click on that, and it takes you to the email app, for example. Right. The second example is what's called a heads-up notification. For example, you're dealing with the photo app, as you see here, and then a text message comes. So it shows up at the top, and you can decide to either reply or archive right there. The third example is a notification on the lock screen, which you can customize, by the way, but it shows certain information about the notification. For example, who is the sender of an email and what is the subject. It won't show up the entire email, but it can show up that much. And then even on the lock screen, you can decide whether you want to respond to it or not. And then the fourth one is an app icon badge. For example, the number of unread messages you can get on one of the messaging systems, or a symbol on this display button, and so on. So these are different ways of providing notifications. And again, we'll see how to do that for your own apps, how to respond to some of the notifications. That concludes the discussion on the API framework. And last layer in the stack is basically the application layers of the apps. It has by default the core apps like the browser, the camera, the phone, and so on. But it also allows all the user apps to go there as well. So in addition to the core apps, you'll have, say, the manufacturer's apps like Samsung and Verizon. So they may have their own apps, um, which also go in the same layer. And then there are third-party apps, which are the apps developed by developers like you and me. Examples can be, say, the Twitter app, which is neither a core app, not even by Google, nor by a manufacturer. A game like Angry Birds, and another example is the Brave browser. Let me talk a little bit about this example. Why I chose that is there is a default browser on the device, but you can create your own browser app and have it installed, which basically can replace the browser, or at least you have an ability to choose whether your browser should be the default browser. Similarly with the camera and phone and everything. So there are no irreplaceable apps except for the settings app. Right? I think that is the one you cannot replace. But even the home screen, the launcher screen, everything, you can have a custom launcher, a custom phone, and that can be your app to respond to when a phone call comes, for example. Okay. System apps also have another purpose. They can serve as a service that other apps can use. So, we have an example of the phone call here, but the other example I just gave was of an SMS app. So if your app requires to make a phone call or send an SMS, instead of creating that capability from scratch, you can simply invoke one of the existing apps like the phone or the SMS, that is the texting app. And you as a developer don't have to reinvent the wheel again and again for all these different purposes. So that way, the systems app serve as a service in addition to serving as the app itself. All right. So this concludes our discussion on all the layers in the Android architecture. As I said in the beginning, there is a lot more to it. We are going to explore a lot of those things in the coming lectures, in the examples, in the assignments that you solve. But I think this gives a nice broad overview of the architecture, which is helpful in understanding how an Android device works and how a developer can interact with different parts of it. Okay. All right, thank you.